In the vast universe, galaxies are not isolated islands drifting peacefully through space, but restless systems bound by gravity, constantly pulling on one another in a cosmic dance that can last billions of years. One of the most striking truths uncovered by modern astronomy is that galaxies grow and evolve not only by forming new stars from clouds of gas, but also by feeding on each other. This process, often described as galactic cannibalism, is neither violent in the way we might imagine nor sudden, but it is relentless and transformative. Larger galaxies exert powerful gravitational fields that slowly draw in their smaller neighbors, distorting their shapes, tearing away their stars, and eventually incorporating them into their own structure. The victims leave behind faint trails of stars called tidal streams, like glowing scars across the sky, silent witnesses of their long struggle against an overwhelming force. The Milky Way, our own galaxy, is not an exception but an active participant in this process. Far from being a static home for the billions of stars we see at night, it is a living, changing system that has already consumed many smaller galaxies over its lifetime. Astronomers estimate that at least a dozen dwarf galaxies have been swallowed by the Milky Way in the past, their remains now scattered throughout the galactic halo. Some of the globular clusters we see today, shining as dense balls of ancient stars, may in fact be relics captured from those vanished companions. Every time the Milky Way absorbs one of these smaller systems, it gains not just stars, but also dark matter, gas, and chemical signatures that subtly alter its composition and history. The concept of a galaxy behaving like a cannibal may sound dramatic, but it reflects a simple fact about how the universe works. Gravity is an inexhaustible force, and in the crowded environments where galaxies are born, they are destined to encounter one another. The larger a galaxy becomes, the stronger its pull, and the more likely it is to capture and consume those around it. This process is not quick. It unfolds over hundreds of millions of years, a timescale almost beyond human comprehension. Yet by studying faint stellar streams and the motions of distant clusters, scientists can reconstruct these events and tell the story of how the Milky Way became what it is today. Understanding galactic cannibalism is essential because it shows us that even something as vast and seemingly eternal as the Milky Way is still evolving. Our galaxy is not a finished creation but a dynamic entity, continuing to change through interactions with its smaller companions. When we look up at the night sky, we are not only seeing a serene band of stars but also the end result of countless mergers and absorptions that shape this magnificent spiral. The Milky Way's history is written in the stars it has consumed, and its future will almost certainly involve further acts of cosmic cannibalism, reminding us that in the universe, growth often comes at the expense of others. Among the many smaller galaxies that orbit the Milky Way, none is more fascinating than the Sagittarius dwarf galaxy, a fragile companion locked in a slow and inevitable battle with our own. Discovered only in the 1990s, it was at first difficult to recognize because much of it has already been torn apart and scattered across the sky. What remains is a faint, elongated system of stars whose orbit carries it around the Milky Way in a looping path that takes hundreds of millions of years to complete. Each time it sweeps through the dense regions of our galaxy, the immense gravity of the Milky Way pulls at it with invisible hands, stretching it, stripping away stars, and leaving glowing trails of debris behind. Bit by bit, the Sagittarius dwarf galaxy is being unmade, and its stars are joining the vast family of the Milky Way as if they had always belonged there. The Sagittarius dwarf is much smaller than our galaxy, containing only a fraction of its stars, and yet its role in shaping the Milky Way has been more significant than its size would suggest. Astronomers studying the streams of stars pulled from it have discovered that these intrusions have stirred up the Milky Way's disk, possibly even triggering waves of star formation at different times in the past. Like a stone cast into a pond, the repeated passages of Sagittarius have sent ripples through the spiral arms, nudging stars into new positions and altering the structure of the galactic plane. What might appear from a distance as a quiet spiral has in fact been reshaped again and again by this small companion galaxy, leaving evidence of disturbance woven into its very fabric. The Sagittarius dwarf itself is a peculiar system. Once, it may have been more massive, but over billions of years of encounters, it has lost much of its material. What remains is a core that still clings to its identity, though the outskirts are already claimed by the Milky Way. Within it lie clusters of stars, some ancient and dim, others younger and more vibrant, each one caught in the tug-of-war between its parent galaxy and the irresistible attraction of the Milky Way. Several globular clusters that were once considered independent are now thought to have originated within Sagittarius, later stripped away and added to our galaxy's collection. This reveals not only the fate of this galaxy but also the way in which our own has gathered some of its ornaments, piecing together its richness from the lives of others. When astronomers peer into the Sagittarius dwarf, they do not merely see a small galaxy on its way to destruction, they see a living example of galactic cannibalism unfolding in real time. By measuring the paths of its stellar streams and the composition of its stars, scientists are reconstructing a story billions of years in the making. They can trace when it first began to fall under the Milky Way's power, how many times it has orbited, and how much of it remains. What they find is a drama of slow but inevitable absorption, a process that reveals both the fragility of small galaxies and the patient hunger of the larger ones. For us, this knowledge brings a strange mixture of wonder and unease. It is humbling to realize that the sky above us, which seems so eternal, is in fact the setting for a long cosmic struggle. The Sagittarius dwarf galaxy, though faint and doomed, offers us a window into the restless life of the Milky Way, showing that even on the grandest scales, nothing remains untouched by time, and survival often depends on being the stronger, not the smaller. The evidence that the Milky Way is actively consuming the Sagittarius dwarf galaxy is written across the sky, though it is faint and requires careful observation to detect. Astronomers have traced long streams of stars that stretch tens of thousands of light-years, arcs that curve gracefully around our galaxy like ribbons in a cosmic wind. These tidal streams are composed of stars torn from Sagittarius during its repeated passes through the Milky Way's gravitational field, leaving behind a luminous trail that marks the path of destruction. Each star in these streams is a fragment of a once cohesive galaxy, now drifting in orbit around the Milky Way, slowly becoming indistinguishable from the stars born within our own spiral arms. By mapping their positions, velocities, and chemical composition, scientists can reconstruct the trajectory of the Sagittarius dwarf over hundreds of millions of years and even estimate how much of it remains intact. The story of these stolen stars is not merely a tale of destruction, but also of transformation. When stars are absorbed into the Milky Way, they carry with them clues about the chemical and dynamic history of their original galaxy. Elements such as magnesium, iron, and heavier atoms reveal the past episodes of star formation within Sagittarius, while their orbits reveal the gravitational influence of the Milky Way over time. By studying these stars, astronomers have learned not only about the fate of a single dwarf galaxy but also about the growth and evolution of the Milky Way itself. In essence, the Milky Way's halo and outer disk are a palimpsest of its many victims, each one leaving traces that allow scientists to read the history of cosmic cannibalism in fine detail. Modern simulations have added another layer of understanding, showing how the process unfolds over billions of years. As the Sagittarius dwarf orbits the Milky Way, tidal forces gradually stretch and compress it, creating waves of density that produce the observed stellar streams. Over time, these streams disperse, and their stars settle into new orbits within the larger galaxy. The simulations also suggest that the repeated intrusions of Sagittarius may have influenced the Milky Way's spiral structure, stirring the disk and possibly triggering bursts of star formation that ripple across its arms. What might seem like random clusters of stars are in fact the echoes of a long, ongoing interaction, a celestial record of a small galaxy's slow surrender to a larger power. Observations across multiple wavelengths, optical, infrared, and even radio, have provided complementary insights into this complex relationship. Infrared studies reveal stars hidden behind dust clouds, while radio surveys map the gas that may have accompanied the dwarf galaxy before being stripped away. Each piece of evidence converges to tell a single, remarkable story. The Milky Way is not a static entity but a growing, evolving system that feeds on its companions, shaping both itself and the universe around it. The Sagittarius dwarf is only one example, yet its streams and remnants make the phenomenon tangible, allowing astronomers to witness galactic cannibalism in real time. The process is gradual, almost imperceptible on human timescales, yet unstoppable on the scale of the cosmos. What remains of the Sagittarius dwarf today will eventually be fully absorbed, its stars becoming permanent residents of the Milky Way, contributing to the galaxy's mass, enriching its chemical diversity, and leaving subtle imprints in its structure. In this way, the Milky Way grows not only by forming new stars but also by inheriting the histories of countless smaller galaxies, a process that has been ongoing for billions of years and will continue long into the future, a quiet but profound testament to the relentless forces of gravity and time. The story of the Milky Way consuming the Sagittarius dwarf galaxy is far from a mere historical curiosity. It is a window into the future and a reminder that galaxies are living, evolving systems. Each act of cosmic cannibalism leaves its mark, reshaping the structure of the galaxy, adding stars, gas, and dark matter, and altering the delicate balance of forces that govern its spiral arms. Over billions of years, these incremental changes accumulate, subtly influencing the Milky Way's shape and motion. The stars of the Sagittarius dwarf, once part of a distinct system, are now woven into our galaxy's halo and disk, their presence invisible to the naked eye but detectable to astronomers who trace their chemical signatures and orbital patterns. In this way, the Milky Way grows not merely by creating new stars, but by absorbing the histories and matter of smaller galaxies, each merger contributing to its complexity and richness. The implications extend beyond the immediate interaction with Sagittarius. The Milky Way's appetite is not limited, and in the future, it will encounter other dwarf galaxies and stellar systems, each destined to be gradually drawn in and integrated. The ultimate collision with the Andromeda Galaxy, predicted to occur in roughly 4 billion years, represents the most dramatic example of this ongoing process. When two giants collide, billions of stars will be redistributed, gas clouds compress to form new generations of stars, and the combined galaxies may eventually settle into a massive elliptical galaxy. In this sense, the Milky Way's cannibalistic behavior today is a prelude to an even greater transformation, a reminder that galaxies are shaped as much by what they take in as by what they create, yet galactic cannibalism is not destructive in a simplistic sense. While smaller galaxies like Sagittarius may lose their identity, their matter continues to play a vital role in the evolution of the larger galaxy. Their stars contribute to the richness of the Milky Way's halo, their gas may fuel new star formation, and their dark matter helps shape the gravitational framework that holds everything together. The process is a natural part of cosmic evolution, a slow but inexorable means by which galaxies grow, adapt, and survive. Each absorbed galaxy leaves a subtle imprint, a hidden chapter in the history of the Milky Way that can be read by those who know where and how to look. For us, observing this process offers both wonder and perspective. The night sky, seemingly serene and unchanging, is in truth a theater of ongoing transformation. Stars that appear timeless have migrated from distant, vanishing galaxies, and the Milky Way itself is still shaping and reshaping its structure in ways that will unfold over millions of generations. The story of the Sagittarius dwarf reminds us that the universe is dynamic, that growth often comes through interaction and absorption, and that even the grandest systems are in constant motion, evolving, and interacting with their surroundings. In contemplating these cosmic rhythms, we gain insight not only into the Milky Way's past and future but into the broader nature of the universe itself, where creation and destruction, growth and absorption, are inseparable threads woven into the fabric of existence.